For the first time in a generation, America is not only launching humans back to the moon, but also keeping a constant presence up in Earth orbit. But here's the thing, not all paths to the stars are the same. So today, we're going to break down the 3 incredible and really different spacecraft that are making America's return to human spaceflight a reality. So the big question is, how exactly do you fly to space in the 2020s? Well, it's not one single answer. It's actually a story of completely different philosophies, different rockets, and of course, different destinations. Okay, let's get into it. Let's meet our 3 main contenders. First up, you've got NASA's very own Orion capsule. This thing is built for the big leagues. We're talking deep space and the moon. Then, from the private sector, we have SpaceX's Crew Dragon and Boeing's Starliner. Their main job is to ferry astronauts to the International Space Station. So yeah, 3 capsules, 3 very distinct missions. First things first, you've got to get off the planet. And that brings us to the most dramatic part of any mission, the climb to orbit. This is all about defying gravity in the most powerful way you can possibly imagine. And when we say power, we really mean it. The Space Launch System, the SLS, that's the rocket that carries Orion. Well, it ignites with a mind-bending 8.8 million pounds of thrust. That officially makes it the most powerful rocket ever built. And it's designed for one reason, to hurl astronauts far, far beyond Earth's orbit. And this slide right here captures 2 completely different ways of thinking. On one side, you've got NASA's SLS. It's all about maximum brute force power for deep space. See, getting to the moon takes an immense amount of energy, so NASA prioritized raw power above all else. Its massive boosters and core stage are expendable. They do their job and then fall away. But on the other side, you have SpaceX's Falcon 9. It's all about efficiency and reusability for trips to Earth orbit. Its first stage famously comes back down to Earth to be used again, and its 9 engines, well, they provide a crucial safety backup if one were to fail. But, despite those different philosophies, the basic playbook for getting off the ground is remarkably similar. First, the main engines ignite with that incredible force. Then, about 2 minutes into the flight, the side boosters separate. After that, the main core stage pushes the capsule all the way to orbit before it, too, detaches. And just like that, the crew is weightless, flying freely high above the Earth. Okay, so once a spacecraft makes it to orbit, the missions start to look completely different. It's no longer about just escaping Earth's gravity. Now it's about masterfully navigating the void to get where you're going. For Orion and its Artemis missions to the moon, this is the make or break moment. It's called the translunar injection. The rocket's upper stage fires one last time, giving this massive push that accelerates the capsule past 24,000 miles per hour. This is the exact moment it breaks free from Earth's grip and starts its 250,000-mile journey to the moon. And this is where orbital mechanics gets really, really elegant. For the Artemis 2 mission, the crew isn't going to have to burn a ton of fuel to get home. Instead, they'll fly a path called a free return trajectory. Basically, by aiming their spacecraft just right, they can use the moon's own gravity to bend their path and essentially sling them right back toward Earth. It's just an incredibly efficient way to travel through space. Now, for Crew Dragon and Starliner, the process is quite different. Their destination is a lot closer, the International Space Station. They perform a series of small, super precise engine burns to perfectly match the station's orbit. And from there, the whole approach is completely autonomous. The spacecraft's computers guide it in for a secure latch. It's this delicate, high-tech dance happening hundreds of miles above our heads. Getting to space is one thing, but as any astronaut will tell you, the mission isn't over until you are safely back on the ground. And the fiery return home is, without a doubt, the most dangerous part of the entire trip. And for Orion, coming all the way back from the moon, that danger is seriously amplified. It slams into the atmosphere at a staggering 25,000 miles per hour. That's Mach 32. This isn't just a re-entry, it's more like a controlled, hypersonic collision with the air itself. That incredible speed creates an unbelievable amount of friction, which generates this wake of superheated plasma all around the capsule. The heat shield has to withstand temperatures nearing 5,000 degrees Fahrenheit. That is literally half as hot as the surface of the sun. The survival of the entire crew depends completely on this one piece of engineering working perfectly. All right, now for the final step, the landing. Both Orion and Crew Dragon follow the classic Apollo-era model. They pop their parachutes and splash down in the ocean, where a ship comes to pick them up. But Boeing's Starliner is trying something completely different. It's designed to land on solid ground, using a combination of parachutes and these giant airbags to cushion its impact, right in the desert. So what does this all mean? I mean, these different capsules, rockets, and landing methods, they aren't just cool engineering. They actually represent fundamental choices about how we're going to explore space. The whole story is really a tale of trade-offs. You've got the raw power of SLS, which you need for the moon, versus the reusability of Falcon 9, which makes flights to Earth orbit way more affordable. There's a huge difference between designing a ship for the long, harsh journey into deep space versus a shorter trip to the ISS. And of course, there's that choice between a traditional ocean splashdown and a modern land-based landing. Each one of these approaches has its own pros and cons, and they shape what's even possible. So ultimately, this all leaves us with a pretty fascinating question. As we stand here on the threshold of a whole new era of exploration, which of these philosophies is going to be the most critical? Will it be the raw power to push us farther than we've ever gone before? The reusability that makes space more accessible to everyone? Or maybe the innovation of a soft landing on solid ground? The choices we're making today, the choices we can see in these three incredible machines, well, they're the ones that will define humanity's future out there, among the stars.